Hello, honors physics students. Okay, so after watching those videos, you should have some really good notes written down for the three different main methods of charging: friction, contact or conduction, and induction. In fact, you probably have more than you need. I just want to go over some of the main points here and add into some of the notes you may have taken. So first is charging by friction. This is literally scraping electrons from one object to another. You notice in the video, in one of the videos, the instructor talks about the fact that you can't just touch the charged object to another one. You have to scrape it, you have to rub it, and friction is required. This is the very same idea as when I rode the balloon on my head or my daughter's head before I stuck it to the wall, before I try to get them to repel each other. You can't just touch a balloon to your head. You have to actually physically move it back and forth, and you have to allow the friction force to pull electrons off of one object and shove them onto the other. So you're literally scraping electrons from one object to another. One of those objects gains electrons, becoming negative. The other object loses electrons, becoming positive. And so assuming that both objects start off neutral, the objects get opposite charges. Now, of course, that's not always going to be the case. Sometimes there will already be a net charge in the system or net charge on one of the objects, but if both objects start off neutral and you rub one on the other, one of them will gain the electrons, the other will lose the electrons, so they get opposite charges. Charging by contact is literally transferring charge by touch. This is also called conduction. And the objects share the total charge. You saw that in some of the animations where you could literally see the electrons going from one object to the other. They share the charge. This is an example of conservation of charge. There's some net charge in the system, and then the charge is spread among the two objects, so they share the total charge. Charging by induction, though, there was no contact necessary. This is when a charged object was brought near, but not touching. And you saw that inside the material, the electrons were moving around as a result of either being attracted to a positive charged object held nearby or repelled away from a negatively charged object held nearby, but they don't actually transfer. Since there's no actual electrical contact, there's no way for the electrons to leave one object and go to the other. They're just moving around within the object. Now, of course, this is different from permanent charge by induction. That's where you saw the charged object held close by, and then an external path was provided by physically touching with your finger the electroscope, providing a path for electrons to leave or come onto the electroscope. At that point, yes, there is contact necessary, but it's still called charging by induction because of the charged object held close by the electroscope without actually having contact happening, without charge transferring between the charged object and the electroscope.